In this session, we're going to discuss Arista's virtual ARP, which is referred to as VARP, not to be confused with VRP, or Virtual Router Redundancy Protocol. We'll cover VRP in a different lesson. Arista's virtual ARP allows multiple switches to route packets for a common IP address and is used for first hop redundancy. This is an active-active router configuration, which makes it different from VRP, where only one device plays the active or master role in a VRP device group. With virtual ARP, each device is configured with the same virtual IP address. A big benefit of virtual ARP over VRP is that virtual ARP allows each device to handle the forwarding of packets. So in a deployment scenario such as Arista's MLAG, where two switches are grouped together to look and act as one switch, we don't have to send any traffic across the MLAG peer link between the switches. Rather, with virtual ARP, whichever switch receives the packet, that switch is permitted to forward the packet on to the next hop as needed. So in this case, with virtual ARP, each switch can answer ARP requests relative to the shared virtual IP address, which is often referred to as the VIP, and each switch shares the same virtual MAC address. The virtual MAC address used for virtual ARP is configured globally. That virtual MAC address will only ever be the destination MAC address. In other words, the virtual MAC address configured for virtual ARP will never be the source MAC address of any frames. And because of that rule, we never have to worry about routers, switches, or hosts complaining of seeing duplicate MAC addresses on the network. To me, one of the most amazing things about Arista's virtual ARP is how easy it is to configure. First, we'll be in global configuration mode and define a single MAC address that will be used by all of our SVIs. Then, we'll drop into the SVI and assign the use of a virtual ARP and the IP address that is to be used as the VIP, or virtual IP, shared between switches. Let's start by configuring the virtual ARP MAC address. We'll do that from global configuration mode. We'll type config, enter, IP virtual-router MAC-address, and then the MAC address we're going to use in this lab is 001c.7300.0099 and hit enter. That's all there is to configuring the virtual MAC address, and we'll need to do that on both switches in the MLAG pair. Remember, you always want to verify your configuration. We can verify our virtual MAC address is in the running config in a couple of ways. I like using show run pipe include space MAC-address and hit enter. And in the output, you can see our IP virtual router MAC address. Another option would have been to use show run pipe include virtual-router and hit enter and receive the same output. Next, we need to configure our Layer 3 VLAN interfaces, which we commonly refer to as the SVIs. In this lab, I'm going to configure interface VLAN 22. So while in config mode, I'm going to type interface VLAN 22, enter, and assign it an IP address 172.16.22.2/24, enter. Here's where we'll configure the virtual IP address, or the VIP, to be shared between our MLAG peers. The command is IP virtual-router, the keyword address, and then 172.16.22.1. And that's it. We repeat the steps on the MLAG peer device using the VLAN IP address assignment of 172.16.22.3. So let's go do that now. We'll type end to get out of config mode, exit to log off this switch. We'll jump over to the other switch in the MLAG peer. We need to configure our virtual router MAC address, so config, enter, IP virtual-router MAC-address, and then 001c.7300.0099, enter. Show run pipe include MAC-address, enter. Verify that our virtual router MAC address is there and matches the one we configured on the other MLAG peer. And now we'll configure interface VLAN 22. Interface VLAN 22, enter, IP address 172.16.22, and in this case it's going to be .3/24, enter, and our IP virtual dash router keyword address, and then 172.16.22.1, enter. We can type N to get out of config mode. We can do a show run interface VLAN 22 to verify its configuration. And there we have the interface VLAN 22, the IP address and the virtual router address of 22.1. And we can type a show IP virtual router command to see our state. So for interface VLAN 22, we're in the default VRF. Our VIP is 22.1. We're up and we're active. And we can do that on the first switch that we had configured as well. Log into that one. Let's do a show run interface VLAN 22, enter. Verify our IP address and the virtual router address 22.1, and then show IP virtual router, enter. And for interface VLAN 22, we're in the default VRF. Our VIP is 22.1, and we're up and active. Expect to be configuring this on an MLAG pair, which is two switches that are sharing the responsibility of providing the default gateway for our servers, hosts, and VMs that are on this common VLAN. But for larger deployments, for instance, a layer 3 VXLAN routing plus MLAG configuration, it's possible for us to use this feature across more than just two top-of-rack switches. A feature that is incredibly easy to understand and configure, and avoids the situation of east to west traffic like may happen in a VRP deployment. You can review the documentation of Virtual ARP and Arista's configuration guide and find helpful blog posts on Arista's EOS Central webpage.